Welcome back at I Need Help at C-Square. In this example, we're going to graph a rational function. The rational function is f of x equals x squared minus 1 over x. First of all, you want to take a look to this rational function and see if you can simplify it. In this case, we cannot simplify, so we can move to these parts. And my first thing will be to find the domain. And for the domain of a rational function, you have to take the denominator, make it equals to 0, in this case x equals 0, and then say that cannot happen, right? If x equals 0, that rational function becomes undefined. So the domain is any real number but 0. Now we can go to part B, how I call it, these asymptotes, and here we're going to have first vertical asymptotes. And for finding the vertical asymptotes, we're going to do the same thing. We're going to take the denominator and make it equals to 0. And that's it in this case. So we have a vertical asymptote at x equals 0, which is nothing else than the y-axis. So you see I drew this dashed red line on top of my y-axis. But then let's take a look to horizontal asymptote. Horizontal asymptote, let me call this part C. Part C. Horizontal asymptote. And if we look for horizontal asymptote, we have to take a look to the degree of the numerator. In this case is 2, and the denominator in this case is 1. Since the degree of the numerator is more than the degree of the denominator, there is no horizontal asymptote. But if you do not have an horizontal asymptote, you want to look for what we call a slant asymptote or oblique asymptote. You can hear both names. And when do you look for slant asymptotes? You look when the degree of the numerator, in this case 2, is larger by 1 than the degree of the denominator, which is in this case true, right? 2 is greater than 1 by just 1. So how are we going to find that? We're going to have to do what is called synthetic division, or long division in fact. And we have here x squared minus 1 divided by x. And we're going to do that long division. X times x is x squared. We're going to subtract these two guys and it gets 0. And then we drop the negative 2, so that is the remainder. So what we're looking at is this x here, the result of the division, because y equals x in this case is what we call the slant asymptote. So I'm going to draw that line. If you remember, y equals x is the line that bisects quadrant 1 and 3, something like this. This is what we call the slant asymptote. So we finish with the asymptotes. We can move to the next part, which is the intercepts. By the way, no holes, because the function cannot be reduced. And intercept. For intercept, we have two intercepts, right? We have x-intercepts and y-intercept. Let's start with the y-intercepts, which means x equals 0. And in this case, if we plug 0 in the function, we remember, look at here or here, that is undefined. We cannot do it. So we do not have an y-intercept. Now let's take a look to x-intercepts. X-intercepts means y equals 0, or the function equals to 0. So you're going to have 0 equals x squared minus 1 over x. Now, this is a quotient. When this quotient is equals to 0, when the numerator, which in this case is x squared minus 1 equals 0, which can be solved, x squared equals 1 or x equals plus or minus 1. So we have two intercepts, two x-intercept. One is 1 and 0, and the other one is negative 1 and 0. And the last part here says points. Points. Sometimes you're going to need more points to get an idea how the graph looks like. Oops, let me plot the other one, negative 1 and 0, right? So you may want to do and see what's happened when x equals negative 2 and x equals 2. Plug them in and evaluate the function, right? You'll notice once you plug them in, for example, negative 2, you're going to get close to negative 2, but it's going to be greater than, it's going to be somewhere here. And when you're going to go to 2, you're going to notice you get a value that is less than 2, so something like this. So that should tell you that's the way the graph is going to look like. It's going to go asymptotic with that slant asymptote, and asymptotic with the vertical asymptote. And the same here. By the way, if you notice, this function is symmetrical with respect of origin yet, because this is an odd function. Maybe sometime you have to have that in your mind when you graph a rational function. It helps. And that's it. We can see a better graph right here. And if you enjoyed this video clip, don't forget to click the like button and come back on C Square for more help. Thank you.